All right, folks. My name is Prithvi. I just traveled from India yesterday. It was a 10-hour flight, but anyways, happy to be here at SREday. I'm working at Mirantis as a community manager. How many of you are practicing chaos engineering here? Okay, I believe everyone's here to understand what chaos is and then hopefully practice it later on. But I started my journey with Litmus Chaos. Has anyone heard of the tool? All right. I saw a couple of hands. So I built that community for 5 years and then left last year and then decided to join SRE Day as a speaker this year. But yeah, we have done a lot of SRE days as a team. And right now I'm working on platform engineering with Mirantis. I'm a senior community manager there and I'm also a CNCF ambassador. I believe CNCF has been painful to most of the folks here, but yeah, being an ambassador, I can't say that. So we'll cut it off record. But yeah, that's about me. And I usually don't prefer talking about agendas because I end up going beyond time. So I keep it to what we'll be talking about, the agenda in hand. That's also something we'll figure out. But let me know when to stop and when you're just done with the conference and when you want to go home, I'll be stopping there. So we have, I believe, these personas in this room. Anyone from marketing or sales here? Sorry, I forgot to mention you folks in this, but I believe these are the most amount of personas who attend an SRE day and who are part of this room. And I still believe that a lot of aspects of resiliency or reliability is yet to be a part of the tech stack or part of the overall infrastructures that have been developed in modern times. And even after we have the concept of SREs, QA engineers, resilience engineers, we don't really have the right practice or the right platform in place to get this into production. And that is why I'm hoping that this talk will make a difference. We'll talk about tooling and we'll also talk about what's something that can help you reach that resilience goal. But this is what is expected out of you, everyone who's in the room. And if I have to translate it, this is the translation of it. Those were hello in 100 languages, but this is a translation of what is expected out of you. I think Miko shared it earlier in the morning, so I decided how am I going to tweak this slide and still bring it in place for you folks. But yeah, if you have to think about infrastructure and how cloud computing came into existence and what was expected around 20 years ago, it was a simple thought process that we'll have a data center and we'll have a public cloud environment. But this is the reality today. We have APIs for everything. There's multi cloud environments, on prem, hybrid clouds. So everyone's, and I believe I haven't seen a large organization focused on one cloud environment, on one particular environment. I was recently talking to some telecom folks and they said that we have multiple companies inside a company, and one team is using GCP and the other is perhaps on OpenShift or VM's bare metal. So this is the complexity that's there, and although we had orchestrators and we have improved it with Kubernetes under the hood, so what was just cloud providers is GKE, EKS, AKS, everything's under the hood. So Kubernetes is seen as a powerful scheduler or an orchestrator, but this is what I believe is the future of operations, or my marketing team might be believing as the future of operations, that Kubernetes is the one source or one scheduler orchestrator that's going to be under the hood for all your environments, data centers, cloud environments, edge environments. There's going to be Kubernetes and a pinch of AI or a lot of AI that's going to drive infrastructures of tomorrow, even if you are trying to build resilient infrastructures. And that is the reality. As I spoke about multi cloud, multi cluster environments, there are different environments, multi tenant in nature, different teams, different countries your teams might be based out of, and different environments. And that is how it's being implemented, and the resiliency of each environment is essential. So, are your infrastructures resilient? If I have, as I spoke about, there are multiple environments. We are missing this model that's a metal to model, full infrastructures. I have seen Kubernetes run on IBM mainframes. So Kubernetes is run on GPUs today. People are expected to learn everything about a platform. It started with DevOps, which is becoming DevOps slowly. But yeah, today the reality is even SREs or engineers are expected to function as platform engineers, where the idea is not just to implement something for the resiliency, say chaos engineering or incident management, but build in a concept of resilience engineering as a platform engineering concept and make an expected outcome of maximum ROI, self service portals, and everything of that sort. And that is where I have highlighted three infrastructure challenges, which is your complexity of tech stacks. Obviously, as I spoke about this a lot, there's a customer experience that's pushing developers and SREs. Customers are wanting everything that works. They are not ready to understand that we are yet to reach that stage, or there can be dialogue. And then, as I spoke about, ROI has become essential, vendor dependencies are growing. And that is, I believe, somewhere it's not helping the SRE persona today. They are not able to reinvent, or they are not able to reach a stage where they will be able to adopt the right resilience practice. And if I have to talk about three critical persona challenges, we have, not sure if this is getting displayed. Can everyone see this part of the slide? Okay. I think I am the one who's just able to see the standee. But yeah, we have QA engineers, SREs, and platform teams and performance engineers. The ideal scenario would be testing your APIs, testing the real world dependencies, hypothesizing around it, selecting your day two operations, ensuring that you are able to integrate chaos engineering or shift left resilience testing into your platforms. SREs and platform teams, they need to have a runbook. A runbook is basically something where you are able to highlight your incident response orchestrations, your alerting, and ensuring that your cloud failures or your downtimes are being mitigated, and learning from your past incidents. An outage can be deadly lethal and cost loss of customer confidence. Your own developer teams might not trust you as an SRE. And a root cause validation, of course. And performance engineers, the disk loss experiments, latency checks, packet loss, performance bottlenecks, mitigating them. So these are three critical persona challenges, or challenges that an SRE has to perform in spite of just being an SRE, but having to act as a developer, QA, and performance persona as well. And people believe that multi-tenant architectures will help them or will support their cause, and they'll be able to mitigate it one by one. But multi-tenant architectures are complex in itself. There might be tenants which are interacting with VMs, or tenants which are directly interacting with hypervisors, or tenants which are directly interacting with your operating system. So you have to ensure that you are having that kind of an ideal scenario where you are actually having an aggregator of a platform which has a hosted control plane, which helps each and every tenant interact with that control plane in itself, have a Kubernetes fleet management, even if you are hosting virtual clusters or clusters on Kubernetes, and then manage your network, your storage, and your bare metal infrastructure as well. I believe everyone in this room, whichever team you're working for, has a bare metal infrastructure. Not really, because I have heard a lot. I have heard a lot of teams using bare metal and looking for resilience testing for bare metal. So we need to move past the legacy approach. I believe that we have moved past legacy systems and we have moved to microservices, but we still have a legacy approach towards implementing microservices itself. So you need to follow an approach where not just microservices implementation or resilience implementation is that manual static or automated testing for CI/CD pipelines only. It has to be composable. You need to leverage what you have flexible in nature if you want to run chaos testing or incident management, or if you want to run both of them together, if you want to run them in series or parallel, you should have that option in place. And that is, I believe, the modern approach to resilience systems. And that is where I'll be covering a tool that helps you leverage a platform first, and then helps you leverage resiliency tools or reliability as a service, or reliability as a state. And this is just my belief. I can be wrong. This is how I believe Kubernetes has evolved from its pre-distribution era to lightweight Kubernetes. Today you can deploy Kubernetes as K0s and like basically need not much CPU, or just deploy Kubernetes anywhere on any OS or any system. And managing this kind of an infrastructure, I believe, requires multiple aspects. You need to be able to manage your different clusters and your different cloud environments. You need to be able to manage different services. I think folks have spoken about a lot of services. There's your ingress controllers, your FinOps, your OpenSearch. There are different stacks that you need to be able to manage, your CNI, CSIs. And that is where I believe we tried to create an open source native tool which helps you not just manage your platforms but then helps you aggregate resiliency as a service. And to be honest, how many of you have deployed, say, a Kubernetes cluster or different multiple Kubernetes clusters? Is there anyone here who has deployed multiple Kubernetes clusters? Have you tried using cluster API alongside it to deploy the multi-cluster environment? I'll talk to you later about how difficult it is to deploy an instrumented cluster API. But this is what we tried to solve, and we came up with this tool called Cordon. It's an open source solution where Cordon acts as a super control plane to manage your multi-cloud, multi-cluster environments. So basically, you have a management cluster, which is your Cordon cluster, and it helps you manage your worker nodes, your different worker environments. But the best part about Cordon is it's not just a cluster manager tool, which is basically what Rancher does as well if people are using Rancher here. But it also helps you manage the state of your or the services, the add-on services, add-on controllers that you use in a platform. And that is where it gets interesting. And I'm talking about resiliency as a service. Is the Cordon State Manager helping you manage your environments? These are some open source components that we have used under the hood. I'm sure these four are not open source components, but yeah, we've used open source under the hood to make sure that the tool is completely community centric, and we believe that this is what will orchestrate all major workloads tomorrow. It can be your Kubernetes, it can be your major workloads. So this is where I'll talk about resiliency as a whole. It's an SREday, so I cannot just talk about cluster management and platform engineering as whole. But you see, this is how the resilience engineering journey has evolved. If you see, we started with the manual testing, static testing, a lot of regression tests were in staging. People didn't have the capacity or courage to move their tests into production easily, and then we moved into automated CI/CD testing. A lot of pipelines, Argo CD and Flux became popular, and a lot of pipeline testing. And then came in chaos engineering, the idea of inducing a fault deliberately into your system in failure induction, injection, shift left testing, GitOps focused. And then people got the confidence to move into production, run a lot of game days, and ensure that they are trying to minimize or maximize their blast radius accordingly. And reliability was measured. You had a metrics in place to measure this reliability, and then it was packaged as resilience engineering. People don't talk a lot about chaos engineering these days. They club it as a concept called resilience engineering, where they are doing chaos, observability, and incident management, incident response orchestration. Everything is packaged as SLO driven resilience engineering. And that, but today I think that has changed as well. This concept has also become predated, and people are not really talking about resilience engineering anymore. But I'll talk about a concept that they are really talking about. So what do SREs need for their effective response? What is essential? It's a lot of text here, but I'll just go through it one by one. SLIs in design, obviously you need to ensure that your SLIs are in place, your developers are working behind it and trying to meet them. Automated chaos, you don't want to run manual tests and just do a pod delete or a pod network loss and be happy. But you want to ensure that your tests are automated, they are scheduled at a particular time, and you're running them the right way. Incident mocks, so the people are promoting game days in their environments. They start small. I would recommend start slow, small, with open source tooling. There's Chaos Toolkit, Chaos Mesh, Litmus Chaos. If you are starting with chaos engineering, I'm not sure if there are a lot of incident management tools that are open source. You go to PagerDuty and the first thing they'll ask you is where's the money. But if you are able to just start small, maybe there are a couple of tools I hear. There's a tool called Respond now that folks from the Litmus Chaos community have built. You can try it out. And then you share the SLIs, the hub. The hub is basically a marketplace where you're building your own experiments or using the predefined experiments. I'll take you through it. and you build a hub for your incident management run books as well. So these are the participants. I believe this is not something which is pretty new, but I have just tried to accumulate how a team functions and how a resilience engineering goal can be met in your organization, or if you are missing out on something, this is something that can help. And this is a maturity model that I was also a part of while they were building it, and then I left the company. But you start small. Of course, you start with less critical services. You start with a simple game day, your CD pipelines, your pre-production environments, because moving into production requires a lot of maturity. And then you automate. You start automating these experiments. You run these chaos experiments as scenarios. A scenario is nothing but running multiple chaos experiments in series or parallel according to your use case. And your goal is to automate and run it in your pipelines. Then you scale, you run your game days in production environments, you collect your reliability metrics, your SLOs, SLIs, and then eventually you become an expert and you start doing chaos engineering lessons all over your teams, or maybe create your own company and sell chaos engineering tools. So this is the reliability indicators. Those who are running reliability tests in production, this is what you are measuring. Eventually your MTTF, MTTR, MTTI and SLOs. But say you are running it in your lower environments just before production. You need to ensure that your resilience coverages are in place, your systems are resilient and they show a resilient score, or you are running probes, maybe an HTTP probe, a Prometheus probe, probes of some sort. You have an incident response plan and incident readiness. And all of these SLIs are what connect them. If you have to ensure that your systems are resilient in production and in lower environments as well, your SLIs are basically connecting or bridging that gap. And SREs, how many SREs in the room? I'm sorry, I forgot to ask. Okay, quite a few. So SREs are basically influencing this, and I was surprised to know not a lot of folks are practicing, say, an incident management or chaos engineering, either of it, to club it up to a resilience or reliability engineering suit. But of course, SREs can influence this. Incident management and chaos engineering are running hand in hand today, and I don't think that it's a niche or a new practice that you'll talk about Chaos Monkey, which existed, say, 12 years ago as a popular tool. So, as I spoke about, these are some open source projects. I'll cover a few more. Chaos experiments, of course, helps you predict what can go wrong, and incident management comes in place when things go wrong. And SREs have to run here and there, but of course you start with game days as I spoke about, and then you respond faster using an incident management tool. So this is litmus chaos as an example, and the thing I love about it is the marketplace. There's a chaos marketplace which has readily available experiments. It started off as a Kubernetes chaos tool, and then it became a chaos engineering tool for other deployments as well. You can write your own experiments. It's just YAML files. You can write them in Go or Python. And that's why it's an interesting tool for me, and it's a good starter pack for a lot of folks in the community. And similarly, if I come to incident management, disaster recovery can be smooth, but you need to ensure that you are having the right tools and the right mindset in place. You are democratizing it, you are talking to your developers, talking to your QA engineers. Has to be a zero cost barrier, enable organizations of all sizes. It's not necessary that you have to work for a large organization. You need to ensure developer experience first. When I started off chaos engineering, it was all about SREs and the testing persona, but I was very surprised by the time I left the company. I was pretty surprised to see that developers have started using chaos engineering or chaos testing in their environments. And then customization, it has to be, you have to give that freedom. Infrastructures are different, people are using different cloud native tools, as I spoke about in the start about the CNCF landscape in itself. You need to be able to customize, and that is where we have tried to create a developer portal that helps you customize it. So this is where we have evolved post the chaos engineering and the SLO driven resilience engineering. There's a concept of AI SRE, which is chaos engineering driven with AI and a lot of MCP servers and in an agentic way. And there's a platform SRE where you're not just trying to implement tooling or a practice, but you are trying to implement resilience as a platform. And this is an example of a developer portal or an SRE portal, you can call it, where chaos engineering comes as a service, disaster recovery as well comes as a service. So both of them can be implemented as a template in your systems. There are other services as well, which we won't really talk about. But that's what Cordon helps you do. So if you use a template for, say, a Litmus or for a Respond Now, for a Chaos Toolkit, for a Chaos Mesh, any tool that you're using for your services, for your monitoring, logging, tracing, or all the aspects of SRE engineering where you're using cloud native tools, you can use the state manager, which is built over the tool called Sweltos, where you can implement all of it as a template in itself. So there are many predefined service templates that are available. We are going to contribute one to the catalog for Litmus as well. So, and then you can use Kyverno for your policies, Prometheus, Grafana, FluentBit for the observability side of things, and then service meshes, Istio, Linkerd, everything's a template. And this is how a template looks. So tomorrow, let's say you want to contribute an open source resilience reliability solution to the stack while you're building a reliability platform. You contribute it as a service template, and this is perhaps my last slide. This is how you're going to implement it. So you see Cordon, the state manager or the cluster manager is there managing your overall environment, which is interacting with a chaos engineering tool. So you're injecting failure, anything, your pod delete, pod kill experiments. You observe the impact, you have your tools there. You can directly run an incident management tool to find your SLOs, MTTRs, but you either after observing the impact, you use an autoscaler, or you use HPA for recovering and scaling and then measuring and optimizing, or your incident management tool goes back to the observability stack and then again it moves on to recovering and scaling and then helps you identify your SLOs, MTTF, MTTR, and MTTI, and other aspects of SRE practices that perhaps will help you measure the impact and make your systems more reliable. I believe this is still a work in progress. I'm hoping that we could build a reliability platform for one of the upcoming SRE days. But yeah, hope this session helped you all. I don't have any conclusion or key takeaways, but yeah, just take a look at Cordon. This is the GitHub for the tool. And yeah, if you are on the CNCF Slack, make sure you're joining the community, asking the right questions, and let's talk more. Let's talk about chaos engineering, incident management, or building reliability as a platform for your tooling. Thank you so much, everyone, for sticking by, and appreciate you just watching the last session for the day. So as we are out of time, I was anyway not gonna do a public Q&A, but as we are out of time, I hope we can meet in the networking session. Let's chat more. Let's talk about chaos engineering or any other resilience practice that you're hoping to implement. And yeah, thank you so much, everyone. Appreciate it.